direction of electrical current. So when you actually switch on something, the electrons from the negative end starts flowing to the positive end. Okay, so it's the electrons that actually moves from negative end to the positive end. But initially, when people started using electricity or discovered and all of that, they considered that something, they didn't know electrons. They just considered something is moving from positive end to the negative end. So conventionally, they consider that things moved from positive end to the negative end, while in actuality, electrons moved from negative end to the positive end. So the direction of conventional current is opposite to that of the direction of actual charge that flows in your day-to-day circuits. Okay. So this is the difference between the flow of electrons and the conventional current. So if someone asks you what is the direction of current, if the electron is moving from, when it's moving from left to right, you have to tell it is right to left. Okay. So it's always opposite. It's a very simple fact, and the reason being people didn't understand, they went with the flow and they considered something, and it happened that things worked that way. But when they actually found out, it was too late to change. Things were in use, so all I had to change. Then they're like, let's continue with this. No issues. As simple as that. So if you want to know a bit more, if you want to understand what is the historical reason and stuff, you can web search. You can read about it. It's your interest. So yes, you have to remember this fact that the conventional direction of electric current is always opposite to the direction of flow of any negative charge. So even including electrons in a conductor. So here I have a question. What is the direction of current? I have the direction of a negative charge or an electron in this case moving from left to right. So what is the direction of current? It is from right to left. Okay. Direction of current is from right to left, while the direction of electrons is from left to right. Okay. Now, what is the direction of current in this scenario? I have a positive charge. How can a positive charge flow? Because I've been talking about negative charge, electron. Well, you have ions and you have positive particles, positively charged particles. Of course, it's not in our day-to-day things that we see this, that you have positive charged particles moving across. In the battery, to be frank, it happens. So but we don't talk about that. Anyways, the question here is, what is the direction of current? If you see a positive charge moving from right to left, the direction of current will be the same thing. So direction of current is in the direction of a positively charged particle, or opposite to that of any negatively charged particle. Okay, so these two are important, and there are quite a few MCQ questions and questions that has been asked as one marker or tricky questions, right? So this fact will help you in those cases, and you need to remember this. These two examples you have and must to remember. Now you can pause and make a note of all of this.